All right, well, welcome to, I think this is session 4. They're going by fast of the SQL study hall. Thanks for joining us today. We're going to talk about grouping, the group by method or clause in SQL, aggregate functions, which you have to use with group by, and how to partition tables. Kind of going to go over that pretty quick. There's a lot of details you could get into in partitioning, but I just wanted to show the use cases that are related to grouping. As always, you could put your questions in the chat or raise your hand. Happy to do anything, explore some odd corners of SQL land. It's kind of fun to figure out. And yeah, we'll just get into it. Hopefully everyone can see this. I'm trying to see. Actually helped it out. Okay. All right. So this session, like I said, we're going to go over grouping and aggregating partitions. So by the end of this, God willing, you'll be able to use a group by clause to group your data across any parameters that are in your source. You'll be able to use aggregate functions to sort of find the average or take the sum and stuff like that. And you'll be able to understand how partitions work in SQL and when you would like to use them. Typically, group by is preferred, but you can use partitions for a lot of the same stuff. So, just to recap from last time we talked about joins. So at this point, if we put it all together, we know how to write SQL statements with joins. Select the columns from a table, join another table, but provide a joining column so that you can put them together in a good organized way. And then you can provide some conditions to filter your data and organize it with an order by. So honestly, following last session, you had a pretty solid way to pull some data, but group by is a common thing you'll want to use to take that a little further and design data sets for reporting and things like that. So let's talk about it. A group by clause, fundamentally, it's used to aggregate data based on the values in one or more columns. You can use this to get an idea of aggregate trends, so you can find like the average per value, you know, that kind of thing. A median, you can do any number of these. I encourage you to just Google, you know, aggregate functions if you like. And you can see a whole bunch of them here. And you got min, max, count, sum, so forth, right? You can also use this, like you saw count just now. It's very useful for understanding how many of each value exist in a column. This is good for checking for duplicates, or if you want to build some kind of, you know, histogram bar graph kind of thing. And you'll recall from last time when we were talking about joins, how important it was to maintain the right cardinality when you join. And group by is a good tool for achieving that. I'll kind of give you some examples of that here in a minute. Good, okay. So the syntax for group by, it's as you might have guessed, you just kind of write the word group by. You do have to put it in the right place. It has to go after the froms, but after the where as well, because it's going to group what you filtered, but before order. You can't order it until you've grouped it. Right? Literally, you just put group by and you put column names separated by commas. So, for example, let's take a look at our data set. We have our COVID data by country. So you can see it's got every region. This is a bit of a misnomer. It's not really by country. It's really by date. Every day, every country gets an update. And then this is the unique ID for the row. You got the confirmed deaths and recovered number of cases for each day for each country. So if you wanted to write a query that grouped on these, it would look a bit like this. So you could write select, maybe let's do country from, sandbox, and we got to give it COVID data by country. Let's give this thing a name, CC for COVID countries. And then you have your from, and you could do where, let's not bother with that right now. Let's just do a group by, and you can group by country. So this is, oh, sorry, it's not by country, it's by region is the name of the column, isn't it? Always important to remember your schema. Okay, so if you run this thing, you get one row for each country because you grouped by the countries, and so there shouldn't be more than one row per country, right? So that's just the basic syntax, the same select, from, and then you can put a group by afterward. If I want to put a where, I can do that here. So let's say where, region, Let's make sure the region has the letter U in it. That's very important to me. So these percent signs, as you may recall, they indicate that those are like free characters, so anything can go there, and then it's got to have a capital U somewhere inside. Okay, so we've got US, UK, and then a bunch that start with U. I guess UK and US do too. Very cool. So as you can see, that's what you do, group by after the where, before the order by, and then the system just scans the columns you provided and selects each set of distinct values once. So there's only one row for each. If you want, you can group by more than one. I think this is the subdivision for this schema. So now you can see, if you add that to the select as well, that there are multiple rows for UK, but each row is a unique pair of region state, right? So even though Bermuda actually has many, many rows on the table for all the days that people had COVID there, there's only one row in my output here. All the other ungrouped columns, so you'll notice both of the columns in my group by are also part of my select statement, but all the other ones are going to be material for me to then perform operations on, right? Now, those are the aggregates functions that we'll talk about in a second. So a little more about this. As you saw just now, when you group by, you are, in essence, creating a new table where the primary key is the columns you grouped on. So if we go back, you'll see on the original table, the primary key was this, S-no. This is just, row number, essentially. Every row of the table has a different number for this, and there are 306,000 rows. However, when I group by, and I don't need to have this somewhat silly region clause in there, now the output is going to have far fewer, only 984 rows in my output, because now the primary key is, in effect, a region state combination. And so every row on this table represents a unique region state combination instead of representing a unique S-no or value like that. So the thing to be aware of that is that you're going to modify the cardinality when you use a group by. Now, you don't absolutely have to. If you are kind of being silly and you group by the primary key, you're going to just get the same number of rows because you actually didn't achieve anything when you did this. You have 306,429, and then this thing, 306,429, because you grouped by an item that was unique, so no change. But in practice, typically you will want to modify cardinality with group by, and you always have the potential to do so. If I wanted to check if the primary key was actually working, I could count the rows and then group them by primary key and count them again, and that would tell me if there was really a unique value. Those numbers should match. Okay, but then this is the tricky part for group by that a lot of people, myself included, often stumble over, and that is, in the original table, you had more than one row per value, right? Like we've just been talking about. If we take this back to what matters, in fact, I'll just make it regions so we can see it a bit clearer. We had many, many rows for each of these, right? UK, US, they had a lot of COVID cases. I don't know, Chad and Cuba, how many, but they had values, right? More than one. But now our new table only has 229 rows. So we have to think that through when we add other values. So here's an example, not maybe a little more visually obvious. So this is my person table, and you can see I'm on there twice, and so is my wife. And when you group us, we have one row for each. But then the question becomes, what do you do with these other values? So I had two phone numbers, but I only have one row in the output. So what should my phone number be in the output? And same thing with Ashley, right? She's got two favorite colors. What's her favorite color in the output? You'll notice if you group by region and then you try to add state, for example, to the column, it's going to give you an error. It's going to say you're referencing a column which is not grouped or aggregated. What that really means is I don't know what state to give you because there's 10 different states that go to your region. So there's no pattern that's been provided to the system to tell you which state you should place in that column. And so it's going to error. Good. The way you fix this is with aggregate functions. But I'm going to pause there real quick. Anyone have questions about group by and how it works to modify cardinality? Okay, cool. Well, the way you get values that you didn't want to group are these aggregate functions. So these aggregate functions will combine the data from multiple cells or multiple rows uh, by using some pattern that you provide, like averaging, minimum value, concatenating. So, for example, if I wanted to know the value of the number of deaths, right? Remember, this is deaths per day on this. If I just run it like this, you'll see that familiar error now. I didn't group on anything. But if I use average deaths, now I'm providing an aggregate function, and it's going to average the number of deaths across all of those. So it's a bit spooky, I guess, but the average number of deaths was 4,370, I guess, in the UK. I'm not sure if those numbers are aggregate or daily. I hope it's not daily. That would be scary. But you can get the idea there. So you can do average. This is the same thing here. You can just use min for minimum, right? So 0, naturally the minimum. You can use max. Let's find the biggest number of deaths. Okay, so on the worst day in UK, there was 112,000, right? So that can give you an idea, but you do have to provide something. I've shown you a few that work with numerical values, but you can also do it with strings. One of the interesting ones is string ag. So I want to keep states and keep that value, the data in my output, but I don't want a row for every different state. So I'm going to do string ag. And the result will be that every state gets kind of jammed together in this field. It's not doing anything clever, by the way, to find the unique values or anything. It's just taking every value. So you're going to have to do a little more if you want to get that cleaned up. You get the idea. Maybe not the best example. Okay. As I said before, every column in your select when you use a group by needs to be either grouped on or aggregated. If you don't aggregate it and you don't group it, the system's like, I don't know what to do with this one because I have more than one for the ones you grouped on. Good. Okay. So here's an example of one where you might use, when you use the aggregate functions, you will put them in the select part of the statement. You are selecting that value from the output, and you are applying a function to it so that it can select something effectively, right? So you can aggregate more than one. You can do some more fancier math if you want, but this is an example, right? You've seen a few already by now, so I'll leave it here for your future. A couple notes on these. First off, an aggregate function doesn't have a name when you use it. You see mine, it came out as F0 underscore, so not exactly very helpful. So let's maybe go back to this one. Average, let's do recovered. Then you've got to give it an alias so it knows, right? And maybe put like that, average recovered. Okay. So now the output has a value, a column name that means something, and I don't get confused. If you do this for many different aggregations, you're going to have like F0 underscore, F0 underscore 1, or F10. It's going to be messy. You can't use this alias, though, elsewhere. So you will need to use the same aggregation itself rather than alias. So for example, let's say I want to find the average recovered, but I only care when the average recovered was greater than 100, right? So I could say where average recovered greater than 100. So this naively, this should work, but oh, sorry, this has to go here. Yeah, you'll get an error, unrecognized name, average recovered. It's because average recovered is the name I gave it. It's not the name that's on the table. So in order to actually use this as a filter, I have to provide the aggregation clause itself, not the alias that I gave it. Well, I don't like this one in where clause. Okay, well, maybe average has a bad problem there, but you get the idea. Okay, so also the other thing to be aware of is that aggregate functions ignore null values. So when it's finding the average, it doesn't think of null as 0 or anything like that. It just doesn't count them at all. So if you need the null values to mean something, you'll want to put like if null or is null, and then change it to a 0 or a white space or something else that makes sense to you. That way the nulls will be taken into account. On their own, they just don't mean anything. The only exception to that is count. Well, there might be a couple others. I don't know everything. Okay, let's look at some actual examples. So we can look at some trends and so forth. So we've already kind of done that. I could do average recovered, average deaths, and average, what's the last one, confirmed? Yeah, oops. Very nice. And voila, right? So now I have the numbers and I can plot these in a graph or something like that. Fun fact, if you're using a program like Tableau or something and using a user interface to like ask it to do this, Tableau is just running this SQL in the back. So you can kind of, I mean, obviously not exactly a SQL, but along these lines, it's using these functions to create the numbers that it then populates the graph with. So you could do this for UK, but now I want to go down to the state region. So you just add state to the group by, and you're off to the races, right? Cool. Good. The other thing you might want to do is check for the counts of different values, check for duplicates, right? So one thing you can do, for example, we have region, then we can do count of the region let's do this as region count. And we'll just get this out of here. We don't need a state. So this will tell us how many times that region shows up in the data set, right? So we have 6,600 days of UK COVID data, but we have 26,000 days of US COVID data, and only 6 days of COVID data from Guam, right? This is a great way to tell if there are duplicates. If you thought that, maybe the names on your database should be unique, then you run something like that, group by the name, and you'll know whether they really are unique, right? So for example, on our person table here, I think the table's small enough that you can just kind of look at it and know. But if we wanted to, we could confirm this by using a group by. So we can say we want the name, and we'll group by the name. Right? And then we'll do the count of the name as name count. And voila, okay, the name count is 1 for each of them. If you wanted to be more programmatic, you could even say where the count of the name is less than or greater than 1. Like that one. Oh, I forgot you have to do it like this. Sorry, guys. You have to select from your select. So sorry, just real quick, does this make sense what I did, right? Instead of putting it in the where clause here, I took the table that was created by this select statement, right, where you have the count of every name. Then I selected from that table and filtered on the name count. So the result of this, if the rows are unique, it should have nothing, right? Or I can check all the unique values by saying where the name count equals 1. Right? So this is a nice way to check for duplicates or build like a frequency data. And then the other key thing, of course, is changing the cardinality for joins. So I have here this COVID data table where the primary key is this number here. This is an ID row for the row. But then I also have a country table. And this table, you'll see a CSV of it in our files if you want to load it elsewhere. But it's just got country level data. The key for this table is the country. And you can join these two. So for example, here's the join of the two tables together. COVID data by country, we're calling it CC, and country itself on C. So if you join these together and just take them all, you're going to get as many rows as there were on the, let me take this limit off, but they'll have as many rows as were present on the COVID table because you're not doing any filtering, you're just taking it all, and many of them match. I don't think you get quite all of them. There's some countries on there that aren't on the country table, but still you have many, right? But you just want to find like the total number of deaths in a given country and compare it to factors like the, I don't know, land area, right? In order to do that, you need to change the primary key on your COVID data table so that it is not so large, right? You need it to just be the name of the country. So instead of just joining directly to the COVID data by country table, you should join to the subset, the grouped by version, right? So you can do like this. We're going to use a subquery now to join onto. Oops. So I'll say from, okay, and then we're going to select the country because we need that to match with, right? And then let's take the sum of deaths. And then we're going to get that from the COVID data table. And we're going to group by, sorry, it's region, not country, right? So let's do that. Oh yeah, we have to give this its name back so that it can join. Very good. Okay, so now if we join, we should have only one row for every country that matches. So it's fewer countries than we had initially because they have to be in both. This is an inner join, right? But nonetheless, you have it one row for each. Again, notice that the thing was labeled badly, right? So it should be death sum, something like that. And now you could have one row for each, and you say to yourself, okay, and now I can easily compare the land area per death by doing whatever else inside this select statement, right? That way, just to recap, the group by modifies the cardinality by making the grouped by column essentially work as a primary key. Since that primary key may be in common with the other tables you're trying to join to, you are going to have the right cardinality now to make a successful join that doesn't bloat your data, right? Okay. Any questions about how that works exactly? Let's talk about some common mistakes. First, grouping by the wrong columns, right? You really want to pay attention to what you group by. For example, in this query, I group by region, but I would have to be paying close attention to what's going on in my table so that so that we can really understand like what are the regions and what are the states. Does every state have a region? Does every region have a state? Stuff like that, so you don't kind of mess up your grouping and get filter things on it accidentally, things like that, right? And as I put a little hint here, don't group by a primary key unless you are very confident that's what you need to do, right? Doesn't really, not if you want that primary key to be actually grouped, right? If you need to group by a foreign key, that might make sense because you want to change the cardinality of the table. But if you group by a primary key, it's probably not going to do what you want it to do. Okay. Okay. The other thing to be aware of, and this doesn't come up that often, is what we could call like non-deterministic aggregation, or in other words, aggregation that doesn't necessarily yield the same value every time. If you were to take the minimum, for example, but there were multiple rows with the same value that were both the same minimum, then you're not like uniquely specifying a row. And then if you join using that value, you're going to fail to uniquely specify things and you're going to kind of confuse yourself. This can happen, for example, if you want to get the most recent value from a table and like use that as part of your join. than most recent date. If there are multiple values with the most recent date and you use it as part of your join, you're actually still going to get a many-to-one relationship, which is not what you wanted. Or you may get the random ID that happens to be picked by the system that shares the lat, the minimum date, and that's not the one you want, right? It's going to change every time you run the query. And then, of course, grouping at the wrong cardinality is very close to grouping with the wrong columns, right? But if you want to have multiple matching values for each distinct value in your grouped column, then either group with both of those in your group by or don't use group by at all. So, for example, in this situation, if I wanted to know like how many deaths happened every month in the UK, I can group by UK, and then I could try to group by date. But that wouldn't really work. Right now I have one for every day. I would need to like find a way to get the month out of the date and then group by that, right? So just be careful with that. You got to really be clear on what is the primary key of the table you're creating. Good. Now, this kind of leads you into using partitions in a lot of contexts, because if you do want multiple matching values for each distinct value on your grouped column, you might want to use a partition. So let's talk about those now. Group by will do probably 90% of the things you need to do with aggregation. So you want to make that your default, because partition is actually computationally expensive and will make your query take longer and cost more if you're in the cloud, right? But nonetheless, you will have situations maybe where you need to group rows together, but you don't want to change the cardinality of your table. So for example, if you want to like assign ordering within a group, so you want to take all the COVID dates for a country and then order them in descending count of deaths, and then like pick the most, pick the middle, right, or something. I guess at that point you're just finding the median, so not a great example, but you can do whatever. If you want to assign some ordering within the value groups, you could do that. You can also use aggregation, do aggregates with partitioning. If the data model is built in a way where group by doesn't achieve what you want it to achieve, aggregation through partitioning might be the right way to do things, and partitioning can also be a way to correct cardinality if you want to use it that way. Cool. So let's look at the actual syntax. Okay, so a partition, like I said, it's used to perform a function over a partition, and the partition is like a subpart of the table that's separated out. This aggregate function is necessary for you to use partitions, at least in the way that we're going to use them here today. The syntax is like this. You put an aggregate function, and then you put over, and then you put in parentheses partition by blank. So all of this goes into your select clause before you name the tables, or really the single table created by joining multiple. So in an example, if you want to get the row number assigned to the elements, you can say row number. So that's the aggregating. Oh, okay, this is actually a window function, but it's close enough for our purposes. We can talk about that later if we need to. So you use a function, right, over the partition. And here you give it a column name and an ordering column, and you can give it an alias too, because partitioned columns, the outputs of these aggregate functions will also be meaninglessly named, so you'll have to give it an alias. Okay, before we get into an example exactly, let's maybe talk for a second about how this actually works. So with group by, recall it's sometimes nice to think about what, like if you had the spreadsheet in front of you on a piece of paper, how could you do what the SQL's doing? In a group by, right, you would like identify the unique values in the grouped columns, and then you would do the aggregations to the ungrouped columns, right, as specified. But partitioning is a little bit different. When you partition the table, you will identify all the unique values in the columns that you're partitioning, right? And then what you're going to do is like cut out all of those different tables, all of those different values, group them together, and create a bunch of different subtables. So now each subtable has all the columns and rows, but they all share the values that you use to partition. So if you partition by name, now you have one subtable for all the Kurashes, another one for all the Ashleys, and another one for all the Moiras. And it's not just the values like you did with group by, it's like the whole little subtable, right? Then you're going to apply some kind of operation to this. That's that aggregate function that we talked about. Like maybe put a row number on each one of these rows in your new little mini table, right? Or maybe find the average. And then last, you take them all and you jam them back together so you get one app table as an output. So the resulting table has the same cardinality because you didn't delete any rows. You just created subtables and then put them back together. No rows went away. But now you have some additional values that you were able to calculate based on these subgroupings, right? So you grouped all the Kurashes together, you found the most common favorite color, and then you put that column into the new subtable. You brought it all back together in the main table. Okay, so that's probably pretty abstract, so let's just talk about it real quick. So here is, actually that one's a little weird. So let's do a simpler one. So we're just going to select star from our Infomar SQL sandbox, and we're going to go to our COVID data table. Okay, cool. So this will just pull the table, right? So let's add a partitioning value to this. We can do it with row number, right? So row number. Okay, remember that's our function. It's just a blank function. You don't have to pass a field to it. So you can put open and close your parentheses right there. And you can say, oops, over, and you partition by, give it a name. Probably region is probably best, right? So let's do that. And then since we're doing row number, let's do an order as well. Let's order it by, what is it? Date of observation date. Oh, did I do it wrong? Oh, okay, good. So what this will do is it'll take all the different regions, break them into their subtables, spit out a row number for every value after organizing them by observation date, and then bringing them back together so that you can see them. And then if we go over here, you'll see my row number column, which I didn't give a name to. Yeah, so it's just counting one up the line by the dates, right? So pretty easy to see what's happening there. Now, if we wanted to, you could use this to find the first date for each, right? So you can go to this. Oops. Take our table that we created by partitioning the other and adding row numbers. And then we can do where the number of the row is equal to 1. So now we're just going to pull the first row from each. So this will mean the first observation date for every country, right? So you can see, or region, I should say, every region now has a one row because they can only have one first observation date. So by using a partition plus a filter, we did modify the cardinality of our original table. And now we have all the different observation dates for every country. The row number is always 1, as you might expect, because that's what I filtered to. And you could kind of go down this list and see what's what. Notice, though, that you could have achieved something very similar to by without this kind of double select thing. You could have just gone to COVID data, grouped by region, and taken the minimum observation date, right? That would have given you the most the oldest observation date, right, and the kind of region. The principal difference here is if you did it with the group by way, you couldn't have included state in that query without also aggregating state because you didn't know because you're using a group by, so you need to aggregate, right? Because this is a partition, I didn't have to do that. I have the row number. And these other values like confirmed, deaths, recovered, these are just the values that happen to be there on that first date, right? So if I want to know what the first day of COVID was like in Macau, I can do that with this partition in a way that I couldn't really do with a just group by. Because if I used a group by, I would have to take the minimum number of recovered, the minimum value from the recovered column, which may or may not be the actual value from the oldest date. Okay, does that kind of make sense? The beauty of partition is that you can select whatever you want after partitioning, but it is, like I said, more computationally expensive and not always doesn't change cardinality unless you do more work. Right? And you can kind of see this. It will be a little silly, for example, if I were to just take my partition and choose, instead of row number, I'm going to do average deaths, right? And then we don't need to call it this. We'll call it average death. And we don't need to order anymore. So we're just going to partition by region, take the average number of deaths, and that's going to apply that average number of deaths as a new column to every row in that region. If you look at the output, so our first region is Timor. You see there's a row for every day in Timor, or every observation. And every single row has an average, and all the averages are the same because they're the average for the whole region. So you probably didn't really need this average value listed on every single column of Timor because it's totally redundant, right? But maybe for whatever scenario you're in, this could be useful. But in this case, a group by would probably have done the work a little better. Okay, let's talk about this. So just like with group by, you can look at some heuristics. So we just assigned that ordering, right? That was that row number. We just did an aggregation, as I just showed you. Obviously, it wasn't like I said, it's not always ideal, but sometimes your data model doesn't let you do it any other way. And you can also correct the cardinality of joins. So let's go back to the example where we did the row number and we always picked the first row. Now the cardinality of this is going to be down to by country, right? Because we only picked one row per country. So because I changed the cardinality, I can select star from Philmarts equals stop country. So there, remember, that was my higher level country data table with things like land area. And then I can join onto this whole thingy. So you can go pretty wild with subjoins. And then the cardinality of this output will be the same as the original ones. Oh yeah, duh. So give this a table. Let's go give it a name. PJ for partition join. On PJ, I gotta give this to .c PJ dot. Should be a field called region in there because we pulled it. Now better equals C dot. I think it's called country. Yeah, good. So we can try this, and we should get, a handful, maybe 200 rows. Yeah, 184. So one for every matching country. And you still have the row numbers at the end, so because we just selected star, but you can kind of see what's going on there. So this is, this example is a bit silly, but if you wanted to find the most recent address on a table, for example, and then only pull that address, you need to find the most recent address. So putting a row number on it by some kind of date ordering, and then pulling the first one or the last one would make sense. But then you can't aggregate the address values because why would you take the maximum address or something like that? That would be incorrect. So you need to find the non-aggregated values there so you can still find those most recent address values themselves. So in this case, not the world's best example, but you can kind of get the idea that you need to find the most recent date. So you can use this. But if I had changed this to be address here, I would be able to pull the actual address values from here without having to aggregate on them at all. Just find the right address values for that date and then bring those into my output. And without modifying the cardinality, right? Because then that person might have multiple addresses. Okay, very cool. Okay, so sort of to recap, just let's talk about it. We have two tools now for modifying or aggregating data in different ways. First, there's group by, and then there's partition by, right? So I just go down the list. A group by does modify cardinality sort of intrinsically, right? The partition does not. So when we just have our partition column, our partition query, there's no change to cardinality. It's only when we later filter on it that we get that, right? Group by requires you to aggregate any ungrouped columns. Because it's modifying cardinality, that raises the question, what do I do with these other ones that now don't have the right cardinality? You got to aggregate them. Partition didn't modify the cardinality, so you don't have to do anything. You can just pick them as they were per row, right? All you did was add more columns here. The group values in a group by will receive the same values. So you can, it's not possible to have a name in a group. If you group by name, you can't get two different values for address, right? They're going to have the same values because you aggregate the addresses in one way or another. But if you partition by name, you could have one row with that name and my name and like one person living there, and another with that name and another person living there, because we didn't have to aggregate those names, right? So this kind of goes hand in hand with the previous. Again, don't worry too much about what a window function is, but group by, for example, cannot do row numbering. If you need to do some math on these kind of grouped areas, that's not aggregation, right? Row numbering is not aggregating. It's like assigning and ordering. Then you can't do that with group by. You will need a partitioning, right? So row numbering, probably the most common example. So I put that there. That all said, it might sound like group by's got some restrictions and partition sounds a lot nicer, but partition is a lot harder. You have to take the whole table and then you have to break it into smaller tables. Now you're dealing with all those independently and then bring them all back together. So it takes a lot more work than just finding unique values and doing some math on some other columns. So group bys should be your default for any time you need to aggregate data. And 9 times out of 10, it does the job. It's only like in certain kind of data model that will force you to partition or in other use cases where you need ordering and things like that. All right, let's sum it all up. So we have a lot of tools, like I said, group by primarily to aggregate data without choosing anything else, partition to break down the table and apply logic to those subunits. Always, as you've seen, I even messed up today, you've got to pay close attention to your data and what's going on in there. You can't just write the code and hope for the best, right? Cool. Well, that brings us to the close of this. Any questions, thoughts? Okay, cool. Well, hopefully it's been helpful. As always, you can shoot me or anyone, well, I guess it's just me, so shoot me questions or anything. I'm happy to help you. These tables exist now in the Lakehouse sandbox, but also in our study hall folder. So if you have your own little database, you can upload country and COVID data and do those different things we did today and mess around with it, have some fun. And I should say this is the last of the 4 sessions we indicated we would start doing weekly. So after today, I think we're going to switch to bi-weekly. And you've got the basis to do more or less what needs to be done in SQL 9 times out of 10. We're going to just start taking a deep dive into, what is a partition table maybe, or how to optimize your queries, how to best practices for building Tableau data sets, all kinds of different things that we can get into more detail on. I just wanted to give everyone a decent foundation to get started. All right, so no class next week, and we'll go back to 2 weeks. And I think the Tableau folks might be happy because we're going to do a shared one here in a bit. So awesome. Have a great rest of your day, guys. Thanks.